Welcome back. In the past few videos we did the USB to UART and all the power circuitry, and today we're going to do the ESP32. And I'm not going to do the auto reset circuitry, and that is because I made a mistake. I'll put a picture up on screen of a working circuit and the circuit that is on this board, and let's see if you can spot the difference. You can pause the video if you like. Well, the difference between the working circuit and the circuit on this board is that one of the transistors has its schematic symbol flipped. That means that in the correct circuit the emitter goes to DTR and the collector goes to IO0. In this circuit, which is the wrong circuit, the emitter goes to IO0 and the collector goes to DTR. So I'm going to leave that off on this board, and I am going to fit the reset and the boot button, and these are enough to flash the ESP32. I also need R11 and R9, which are some series resistors on the UART lines. I don't need R8. R8 is a extra pull-up on the reset line, which according to the datasheet of the CB2102 helps with stability, but for this test it's not needed. I do however need a capacitor on the 3.3 volt rail near to the ESP32, and also a capacitor on the enable line and a pull-up on the enable line. And that's basically it, so that should be reasonably quick. I hope to also do in this video one of the stepper drivers and see if we can drive a stepper motor. And just as all the other videos, I'm going to do all the soldering, except maybe for the stepper driver, under the microscope so you can have a better view. Alright, I should be able to program it now, but just to be sure, let's see if there's no shorts anywhere, or at least between 3.3 volts and ground. This is a ground point, and this is 3.3 volts. So let's plug it in and see if we can program it. Oh yeah, I forgot something. I was just telling you about the auto reset function not working. So I need the reset and the boot button, but I haven't done that yet. So let's do that real quick. Now let's try it with the boot and reset button. Now I have to put it in bootloader mode, and you do that by disabling the ESP32 or just pressing the reset button, then pressing the boot button, then releasing the reset button, and then releasing the boot button. And I have to do that at the moment it wants to upload the sketch. Press reset, press boot, release reset, release boot, and now it should start uploading. It doesn't want to upload. Alright, I'm back. It was some debugging. At first I thought, because I did have some debug information over the serial from the factory ESP32, that it was something to do with the RX and the TX and the resistors that were there. So I just removed the resistors and jumped the footprint to see if that made any difference, but it didn't. Then I thought, well, what could it be? And I decided to put a lot of flux around the pins of the ESP32 and just reflow them all, and that actually did the trick. I can now upload sketches to the ESP32. So let's see if that actually works. Put my multimeter here so you can see it. And I have ground over here. And GPIO 16 is that one. Yeah, and that is blinking away. Let's put in some pin headers and solder in one of the TMZ2208 and see if we can, well, maybe even drive a stepper motor. So I have some female headers over here and some TMZ2208, and I'm going to put one in the headers so that I know when I solder it to the board, the TMZ2208 will actually fit in there. Let's see, for this it really doesn't matter, but let's put it in the right orientation anyway. I thought it was this way, but this should fit. Hold it down and do the opposite side. Hold it down. Let's see if this is straight. You can't really see that. Yeah, that's okay. Oh, this is the ground one. You know what I'm gonna do? I'm just gonna skip the ground one for now and do this one and this one, which is actually ground again, so do this one. And then I'm gonna remove the TMZ2208 so I can hopefully dump some more heat into those ground pins. Let's also raise the temperature to, well, 400 degrees. Alright, that's the headers done. Let's do one of the JST connectors. I'm just going to do one mounting pad first. And what is an easy way? I think this way. Oh, should have actually unplugged the USB. No real biggie, but just in case I short something out using my soldering iron. Let's do it like this. I'm just going to do it by eye. Make sure it's about right. Oh. Yeah, that's about right. To the other mounting connection. And now do the pins. Oops. Just trying to make sure I don't burn the female headers over there. Yeah, that's in. So now I need a stepper motor. There's one. And a cable. This is one of the cables I used for testing on the breadboard. I disconnected the connector that was on there and put some breadboard wires in there, but now I have to put the female connector back on this cable, about there. Bye bye. And that's those done. I think these are a good length. Now I have to get some JST-PH terminals and one 6-pin connector. Crimp it. And those are the strands done. Now all I need to do is crimp the insulation. First I need to close it a little bit. Like so. I think 1.6 will do. Oops. Yeah, that's on there. Yeah, pretty tight. Let me do the other 3. Alright, that's those 4 done. Now before I plug them into the connector, I have to make sure that I get the coils right. So in the schematic I have imported a picture of how it should be. So I need 1A and 1B and 2A and 2B. So 1 is one coil and 2 is the other coil. And if I look at the connector like this, then the 2nd pin and the 5th pin are empty, and the 3rd and the 6th pin are one coil, and the 1st and the 4th pin are one coil. Now there's 2 simple ways of knowing which wire is which coil. The first one is just by a continuity check. Plug it in, set my multimeter to continuity. Not this one, this one. So that one has continuity, and then the other 2 should have continuity as well. There's also another way you can check this, and that is if you leave all the wires floating like this, you can pretty easily turn the stepper motor. But if you connect 2 of the same coil, you can feel a lot of resistance. So that's another way you can check which wire goes to which coil. Let's see if it actually plugs in. That would be handy. This way. Yeah, that's a snug fit. Let's get it out and let's upload some code. The code I'm using is an example from the Excel stepper library, and it just sets the speed and then runs the stepper. Now I haven't set the voltage reference for the current to the stepper motor, and I also haven't placed the heatsink on the chip yet, so I'm not going to run it for long. But I have some tape around the stepper motor so you can actually see that it's turning, and well, the only thing left to do, turn it on, hope the fuse doesn't blow, and we see some turning. Here goes. And there we go. The stepper motor is turning very slowly, but it is turning. Let me turn it off again because I don't want the chip to desolder itself. So that is working. The next step is to do the other stepper motors and do the limit switches, and then test all the motors and the limit switches and then I can finally get back to building my camera jig.